Welcome to my series on exploring options for running containerized web applications on Azure. There are quite a few. I would like to show you Azure Container Instances, which I'm very excited about, and Azure Web App for Containers. We will also cover Azure Container Registry. In this part, I will create a web application and prepare it as a container image that I could use for my future deployments. I know I can create C# and .NET apps on Azure, but I also know that we can do so much more because containers make it possible to bring a big variety of platforms on Azure. So I'm curious of how simple would it be to run a JVM-based web application in an open source functional programming language on Azure. So why don't we try it with Scala and its Play framework? And I use it for some projects. So in this part, I will build this app, publish it to Docker Hub, and in the next videos, we will deploy it. So first of all, I'm going to create this app. And I got Scala and installed SBT, which is a Scala build tool. And I also checked my SBT version after installation, which you can do using the SBT version command. And if there is a project that you want to use, you can definitely use it. And I will create a project from a Play template using SBT. Like this, SBT new, the name of the template. It also will ask us for some versions to make sure that the project has exact versioning we need. So I'm just putting my versions. And exact versions of these libraries you can easily find in Maven Central repository. So next, let's run SBT run or compile and make sure that there are no errors when we build this project locally. And this step also needs to be done from the project example directory. So SBT run, and as a result, we should see that our server is running, and we should see the address and port it's running on. So here is our address and port. And if we enter it in the browser, we should see the page that we expect. And here it is, everything works. Now let's take a look at the project structure because it's really important to understand. And the main file here is called build.sbt. We also have projects directory, conf directory, and app directory. So build.sbt looks like this. Here we have name, organization, version. It's a good place to enable some plugins. And this is the right place to indicate all of your project dependencies. And as a last line here, I am indicating my Docker plugin. So another important file is called plugins.sbt. It is located under project directory, and we can use it to add various plugins. For example, SBT plugin was already here by default, and I have added a native packager plugin that will help us to build a Docker image right from the solutions directory. Application.conf file is located under conf directory, and it can be used to set Play HTTP key, to disable or enable some of the default project filters, and many other configuration things. So Play uses this so-called secret key to do things like signing session cookies, CSRF tokens, and to do some built-in encryption utilities, stuff like that. It is also possible to create a file called production.conf if you would like to set some of these values to different values. So reference.conf file here, we're just allowing access to some of the host names that we know we're going to be accessing our web server from. And there is a home controller file, and it serves as our web page when we're accessing our server. So let's now build our local Docker image, and we can use sbt docker publish local command for that. Sbt docker publish local should create a local Docker image for us. And we can check that this image exists on the local machine by running docker images, and we will find our latest image created. So now that we have our image built, we can push it to the real container registry. And there are several options on how to do that. We can deploy it to Docker Hub or to Azure Container Registry or something else. So I have a Docker Hub account, and I created a repo called AZ-Scala, and this is what I'm going to use. So after we have our repository name, we can push our local image. And the first step here is to tag the image. So we can use docker tag command, indicate the name of our local image and the name of our remote repository we are going to be pushing to. And after the tagging is done, the new image with the familiar repository name will be in the list when we run Docker images. So we're just pushing it using the docker push command. Great. In this part, we have created a Scala Play application, built a container image, and deployed it to Docker Hub. Now we have an image name, which we will need in the next video, where I'm showing how to create Azure Container Instance for it. Thanks for watching, and don't miss the next part.